Agricultural ditches are essential components of many farming operations, given the abundant rainfall and high water tables throughout much of Florida. An effective ditch network functions primarily to convey or distribute water without causing excessive erosion, water loss, or off-site degradation of water quality. Properly designed and constructed agricultural ditches are very important. However, equally important is an ongoing maintenance program to ensure that ditches will continue to function as designed. The size of ditches will primarily depend upon the drainage characteristics of the land and the desired conveyance capacity of all ditches combined. Caution must be exercised when constructing ditch banks so that ditches will remain open. Ditch bank side slopes in very sandy soil should be constructed with a minimum slope of 3 feet horizontally to 1 foot vertically, or a 3-to-1 ratio. There are many factors that influence the flow of water in open ditches. One of the most important of these is the cleanliness of the ditch. Weeds and debris, if allowed to accumulate in open ditches, will decrease its capacity. Grass and weeds may also grow in open ditches to such an extent as to reduce the capacity of ditches to less than half. It is important to routinely dredge ditches to maintain open ditches. Small open ditches are usually constructed with a V-ditcher. Many vegetable operations use semi-enclosed seepage irrigation, where water is distributed from a header pipe and conveyed within the field through spigots that discharge into lateral ditches. This type of irrigation system is common on flatwood soils that have a spodic horizon. The naturally high water table on these soils is raised to a level where water moves into the production bed by capillary action. In the flatwoods, the naturally high water table must be controlled and provisions must be made for the rapid removal of excess surface water from rainfall. Control of water table is achieved via the construction of evenly spaced ditches in addition to the beds. The use of drain tiles may be employed, particularly in problem areas resulting from general non-uniformity of soils. However, some growers routinely install drain tile to control the water table. A survey will also help determine if leveling of the land is required. Open ditches and water furrows may be required to remove the bulk of surface water. Drains should be installed in the direction of greatest slope. There are several important soil factors that should be obtained from a soil survey of the area prior to design of the drainage system. These factors include soil type, thickness of various soil layers, continuity of soil layers, position of layers with respect to ground surface, hydraulic conductivity or porosity of the layers. Several water factors need to be considered to ensure a proper design of the irrigation system. Lateral drainage ditches should be cut at right angles to crop rows, and water furrows spaced no further apart than 1,320 feet center to center. Drainage water from several lateral ditches may run into collector ditches and is conveyed off-site. Discharge pumps are required where there is insufficient relief. Size of the collector ditches and any related pumping facility is dependent on several factors, such as size of the area being served, soils, bed and water furrow design, and slope of ditches.